Okay, day 9. Oh, it says day 10 here, but it's 9 in your packet. I forgot to change it. I'm sorry. So, day 9, more on proofs. So, a quick warm up. We're going to write a proof using this picture here. Given that y and z are parallel, w and x are parallel. So, let's just start with that right off the bat. And we'll say y parallel to z, w parallel to x, given. Okay? I'll try to prove 3 and 9 are congruent. 3 and 9. Which you can tell are both the acute angles in this drawing. So again, we can do a lot of things. We can go from 3 to 16 by alternate exterior, and 16 to 9 alternate exterior. We can go 3 to 11 corresponding, 11 to 9 corresponding. We can go 3 to 1 corresponding to 1, 9. It makes no difference. You have options. So I'm going to say that angle 3 is congruent to angle 1. And we say if lines are parallel, that's how we justify it, corresponding angles are congruent. And then I'm going to say angle 1 to 9 and I'm going to actually just, you can do that, you're doing the same thing. And then we can say angle 3 is congruent to angle 9, and we use the transitive property. Just a quick review. Now we're going to go through what we know about these different terms. Now we have been going one direction, we're going to go the other direction now, and say the corresponding angles are congruent, then the lines are parallel. So we've been congruent the other direction. If lines are parallel, corresponding angles are congruent. Well, we're going the other direction and saying if we know the corresponding angles are equal, then the lines are parallel. And we're doing the same thing here. You can kind of see where we're going. If alternate interior angles are congruent, then lines are parallel. Now, I guess we'll put a picture in here. So, if we know the corresponding are congruent, then we know these two lines are parallel. Down here, if we know that alternate exterior angles are congruent, then we know these two lines are parallel. Alternate exterior angles. Again, similar idea. If alternate exterior angles are congruent, then lines are parallel. That's not parallel, that's congruent. Whoa! I don't want to do that. What just happened? I love technology. Oops. I apologize. Down here on this one, I did exterior angles. So, alternate interior there. I am sorry. So here, alternate exterior shows you that these two lines are parallel. Same side interior. Well, we've been using a different term. We've been using consecutive. It's the same thing, same side interior, because they're on the same side of the transversal. But we're using consecutive now. If consecutive interior angles are congruent, lines are parallel. Well, they're not going to be congruent. That's just silly. Because they can't be. Because one's obtuse and one's acute. So if they're supplementary, take the picture to make my brain wake up. Those two angles, if they are supplementary, then we know we have parallel lines. Here's a new one. If two lines are parallel to the same line, then the two lines are parallel to each other. Then kind of a transitive property. So I have M, N, and P. I say if M is parallel to N and P is parallel to N, since they're both parallel to the same line, then M is parallel to P. So it's kind of a transitive property here. If we know this is parallel to this, and this one is also parallel, then they're all three parallel, really. Perpendicular angles. Two lines are perpendicular to the same line. Then the two lines are parallel to each other. This is called the perpendicular transversal theorem. So what does that look like? Well, what we're saying is P is perpendicular to M, and N is perpendicular to P, or we could say P to N. Therefore, since they're both perpendicular, we know that M is parallel to N. It just has to be that way. All right, so let's look at which of these lines are parallel. And that, on mine, it was on the previous page, but it's at the top of your page. So, state the theorem used. 1 and 7. Well, that proves that X and Y are parallel. And by which rule? Alternate exterior. Okay? 3 and 19. Here's 3, here's 19. Well, they're corresponding to each other. And since they're inside and outside of these two lines, that proves that A is parallel to C, and that's my corresponding. Okay, 5 and 13. Here's 5, here's 13. Once again, 13 is inside, 5 is outside, same side, so we know it's corresponding again. And that proves that A is parallel to B. 4 plus 8 is 180. 4 plus 8. Well, those are on the same side of this transversal, interior to these two lines. So that's obviously consecutive interior. And what does it prove? It proves that X and Y are parallel. 7 and 23. 23, here's 7. Well, those two are, if you kind of forget about this being here, skip over that, 7 and 23 are on the same side of this transversal, and they're inside these two lines. So they are proving that A is parallel to C. And that's again consecutive interior justification. One's obtuse, one's acute, they're going to add up to 180. 6 and 14 are congruent. 6 and 14. Well, they are on the opposite sides of this transversal, and they are both outside those two lines, A and B, which are the two lines that are parallel, and Y, alternate exterior angles. 5 and 21. 5, 21. Again, imagine that's not there. Okay? Same side of Y. One's inside, one's outside A and C. So it's proving that A is parallel to C, and that's corresponding. We're almost there. Find X so the two lines are parallel. Well, if they're parallel, we look at these two angles. This angle and this angle are alternate exterior. And alternate exteriors should be equal if the lines are parallel. So we're going to use the alternate exterior theorem, and we prove 5x plus 53 equals 8x minus 19. Well, if I subtract 5x, I get 3x. And if I add 19, I get 72, which means x is 24. If I plug in 24, I do 24 times 8 minus 19, and 24 times 5 equals 53, I'll get the same answer, which proves that the lines are parallel. Okay, these two. Well, this one and this one are opposite sides, but inside, this has alternate interior. So again, I'm going to set them equal to each other. The funky x, but we'll go with it. I'm going to subtract x and get 3x. I'm going to add 15 and get 42. Divide by 3. No, sorry. This is supposed to be a 2x here. That's probably why I made that funky x. That makes this 2x, which means x is 21. Sorry for the copy error. If I plug in 21, 2 times 21 plus 27, 21 times 4 minus 15, get the same answer. Proves that these two lines are parallel. Almost there. Okay. Outside, inside. If they are congruent, if they're corresponding, if I can prove that those are congruent, then subtract 3x, add 6, x is 12. plug 12 in. I do 12 times 4 is 48, minus 6 is 42. 12 times 3 is 36, plus 6 is 42. Therefore, since they're both 42 degrees, these two lines are parallel. Alright, these two are not the same because one's acute and one's obtuse. They're same side interior or consecutive interior. Since they're consecutive interior, they must add up to 180. So I get 8x plus 28 equals 180. If I subtract 180, I get 8x equals 152. If I divide by x, I get x equals 19. I believe. 8 times 9 is 72. 8 plus 7 is 15. Good. Now if I plug 19 in, 3 times 19 is 57. Plus 10 is 67. And 19 times 5. 5 times 9 is 45. Carry the 1. 5 plus 4 is 95. Plus 18. 113. And 113 plus 67 is 180 degrees. So that proves that these two lines